So at the beginning of the chapter, we graphed and we did a lot of stuff with exponential growth or decay, and then we did a little mini section on the number e. You may remember, you may not. It's okay. It's been probably about a month since we've done that. But today we're gonna pull back e, and we're gonna do a little bit of that. And then also we're going to do something called a natural logarithm. And these two things are paired together because these two things are opposites of each other. So whenever they created the number e, since e is an exponential equation, it needed its own special logarithm to solve it. So that's where they came up with the natural log. Because e they call the natural base. And you can see all this stuff on your paper. I'm going to go step by step so I can talk about it. So remember, e is a number. It stands for this long non-ending number, just like pi, so 2.7182 and so on. It's just programmed into every calculator. There's actually a couple different e's that are used in every scientific calculator. So the e that we want to use, because eventually we're going to have to evaluate something like this. I'm going to give you like e to the second or e to something. The e that you want to use in your calculator is e with a little x. So every calculator should have this feature somewhere. A lot of times it's second of an ln button, because we're actually going to talk about ln today, natural log. So up here, I don't have e originally, but I do have an ln button. Usually it's paired right next to log, because, like I said, ln actually stands for natural log. Usually e is a second feature of that. So once I hit second, then my e to the x feature showed up. If you look at all of my blue calculators, we had the second, then log was underneath it. Underneath that is the button ln, and the second feature of ln is e to the x. So these two things are paired together, the e and the ln, because they are opposites of each other. So to solve out e to the second power on my blue calculators, I would just do second ln, that would get me e, and then I just type the exponent of 2 and then hit equals. Up here I actually have to hit the exponent first, so then e to the second, hit 2, and then I hit my e button. But ultimately every calculator's format is going to look like this. E and then has a little exponent symbol, and then type the exponent. So e to the second power is 7.389. So to ask you to evaluate an E or solve an E or anything like that, use your calculator. E should be programmed into every scientific calculator, and what E is expecting is exponents. So that's why a lot of times the E button is E with a little X. And most of the time, it's not its own separate button. Some phone calculators have its own separate button if you turn it on its side. Most of the time, it's a second feature of the ln button, which we're going to talk about. Ln is that. Ln is a special logarithm. It's a special function. It's called the natural log, but the abbreviation for it is actually ln. I don't know if they did that to keep it in the log family, because log it starts with L, so they wanted ln to start, or natural log to start with an L as well. But what it is it's base e. So when you see it typed, you're just going to see the letters ln, and that stands for natural log. It does have a little base like all logs do. The little number next to the n, now since it's not log, it's natural log, is actually e. Some calculators will actually put the little e there, not always, but again, natural log's base is e. So it's always e. There's no other base we ever put on natural log. So that's why usually when you see ln typed or written, you don't see the e there. But there is a little base on the ln, and that is e, because this was created to be opposite of e. So it helps us find exponents on e when we need to, or e helps us find stuff with ln. So these two things are opposites of each other, even though they don't really like look anything alike. And just like before, we can solve stuff on the calculator. The nice thing about ln is it's its own special button. So unlike what we had to do with logs to solve out just like log base 5 or log base 6, ln is programmed into the calculator as is. And so really the only thing you need to do to solve out ln is just use the ln button, which is below the log. So to solve out ln of 3 on my blue calculators, I just hit ln, then type 3 and hit equals. And that's all you have to do to solve out ln. So it's 1.098. On my board calculator, I just have to type the number first. So if I hit 3 and then the ln button, I get that. I guess I should have rounded that to 0.099, but nice thing about natural log is it's its own separate function. You don't have to do anything special with ln other than use its programmed in feature. Okay. Like I said, some calculators you have the number first, then the ln button. Sometimes you have the ln and then the number, but ultimately, unlike other bases for log, it has its own special feature on every scientific calculator. So you don't have to do the whole dividing thing or anything like that. You just do ln 3 equals, and you should be good to go. So then what we're going to do with these now, because these two things we've kind of kept separate from all the other exponentials and logs that we've worked with, we're actually going to go through, we're going to do every little bit with those. So this was the evaluation part. Now we're going to talk about how we can rewrite them, because these two things are opposites of each other, but they don't look anything alike, because one's an E and one's an ln. But if you use our rewrite, our walk around process, you can actually take something from E form and rewrite it into ln form and vice versa. So we're going to do that first, and then we're going to talk about how to solve them. So everything we did with logs and exponentials, we're kind of throwing it all together with these new functions, E and ln. We did a little bit with E when we looked at these graphs, but ln we haven't talked about. So for these, kind of the crazy thing about them is they look similar to the equations we're going to solve, so you really have to pay attention to the directions. Sometimes the directions will say this, right into equivalent expression, and so when you see this direction, what it's asking you to is just to rewrite it. Okay. So if it's in E form, you're going to rewrite it into ln form. If it's in ln form, you're going to rewrite it into E form. So you're not really solving it, so that's why you have to kind of pay attention to the directions a little bit. So if you see just right into equivalent expression, anything that starts off as an E, we're going to rewrite it into its ln form. Anything that starts as an ln, we're going to rewrite it into E. We're not really worried about solving for x, even though there's x's in all this. But so we're going to take it from what we start with, rewrite it into its opposite. Again, practicing that feature so we can go back and forth between E and ln. Because eventually we're going to use it to solve. So this is in E form because it's E to the x equals 5. So to write into an equivalent expression, we're going to write it into a natural log. So we're going to start with E, but when we rewrite it, we're going to write in our natural log version of this. Now if it helps, where E goes is actually down here next to the n. So if you want to write it there for the first one, you can. But usually, since ln's only base is E, we don't usually see E written. But this is where you can kind of keep track of where E goes. So E is the base of ln, so it's the little number next to the n. And then we use our walk around method to rewrite this. So then we walk around to the 5. So then 5 just goes next to the ln. And then it equals the exponent. So we can rewrite this exponential of E into its ln form by using that same walk around method. It's just now we're using two different features. So like I said, this is how you could write it, but most of the time when we see this written, it's just going to be ln of 5 equals x. Because usually we don't write that little E next to the ln, because that's the only base you ever see with ln. So usually we just write it ln 5 equals x. Okay. So I'm going to circle that one, because that's typically what we write it as. If it helps, you can write E there, but you don't have to. That makes sense? Mm-hmm. So now we have E to the 7th equals x, so we're going to rewrite it into its ln form. So we have ln, we could write E here, but we're not going to. So the E is going to change to ln, and then we walk around to the x, and then it equals 7. So again, if you see the direction right into equivalent expression, all you're doing is taking it from one form to the other. So if it starts as an E, rewrite it into ln. Starts as ln, like these next two. Now we're going to rewrite it into its E format. And if it helps you with this one, you want to jot in the E, you can, so that way you can see where the E goes. But here this is an ln form, and we're going to rewrite it into E form. And we're still going to use that same kind of walk around method when we wrote it from the log to exponential. So this is in log form, because ln is a natural log. So we're going to write it from ln into E. So, like I said, technically the E is there, so the little e becomes the big E. And we walk around to this number, which is really easy on this one. Okay. Not actually that crazy, but it's 3.1438. Okay, and then it equals the x. So that's the E format of that ln expression. So we have ln of 18 equals x. So we're going to rewrite it into an E. What's that going to look like? E
Equals 18.
So this was an ln format. We rewrote it into E. So you can evaluate them using the calculator. So we talked about that on the first slide. And then we can write it into equivalent expression, which is the rewrite process. Just taking it and applying it to this form, these functions. So now, the other thing we did with logs was we solved them. So that's what we're going to talk about now. We're going to take E and ln equations and solve them for x. And we're going to use this rewriting process to help us. So whenever we solve ln and E equations, there's really no other process to do it. We have to rewrite it. So if something starts off as an E, you have to rewrite it into its ln form. If something starts off as an ln, you have to rewrite it into E in order to solve it. So this one, the exponent is where the x is at. So it's trapped as the exponent of E. So in order to solve this, we need to rewrite it into ln. So we're going to take it from E and rewrite it into ln. So the E changes to ln. Again, if you technically don't write where E goes, it's the little base next to n. Is it okay that I don't write that? So we use our walk around. So it'll be ln of 15. Again, 15 is not an exponent. It's not the little base. It's just next to the ln. And then it equals the 4x plus 3. So now to solve it, we use our handy dandy calculator. So the next thing you should do once you have it rewritten from E form to ln form is you're going to use your calculator to solve out that ln, which every calculator has an ln feature. So you just need to do ln of 15, which equals 2.708. Like I said, yeah, some calculators you have to type the number first, some of them you have to type the ln first, but ln of 15, solve that out next. So that's where the 2.708 comes from, just from the calculator. And then from here on out, we just need to finish solving for x. So then what's our next thing we need to do? Subtract 3. We'll take the 2.708 minus 3, which is negative 0.292, and that equals 4x. And then what's the last thing we need to do? 4. And there's our solution. I will say with these types of equations, you are going to be looking at some kind of strange decimals, just like we were when we solved the exponential equations, because ln and E always give you a decimal, because E is already a decimal, and then E is the base of ln, so they're all decimals all around. I just have one more E equation, and then we're going to look at some ln equations. This one is a little bit different, though. What do you notice that's around that E? There's a 4 and an 8, okay? So what we have to do before I can rewrite it into ln, any of the extra numbers, which is actually 2, there's a 4 and an 8, we need to move those around. So before I can rewrite it into ln, I need to move the 8 and the 4. Which one should I move first? The 8. Yep, we're going to subtract that 8 first. We have 4e to the negative x, and that equals 9. Actually, it's a better number to divide. So now, how do we get rid of the 4? Divide. Okay. So here's where it's kind of a personal choice. If you want to turn that into a decimal, it's not too bad of a decimal 9/4, or you leave it as a fraction. I'm going to leave it as a fraction. That's just typically what I do. It doesn't divide evenly. So if you want to divide it out, go for it. fraction. Like I said, it's kind of your personal choice. So we got the numbers around E moved. So now what are we gonna do?
Make it ln.
Yep, we're gonna rewrite it into ln. So I'm gonna move that up here so it's not quite so low on the screen. So we're gonna walk around, so it'll be ln of the 9/4, and again where the E goes is right next to the E at the n, and then equals negative x. So in my calculator, I just need to do ln of 9/4. If you're on a calculator, you have to type the number in first. I will say, if you do 9 divided by 4, make sure it equals before you hit ln, otherwise the calculator won't read it right. So if you're on a calculator, you have to type the number first, do 9 divided by 4, and then it equals, and then ln. So ln of 9/4 is 0.811. And then what's the last thing I need to do? Yeah, we need to get rid of the negative. I just divide that over there. So yeah, negative 0.811. Questions on E equations? Like I said, we're still using that same process we solved all exponential equations. The biggest thing is it's kind of strange looking because it starts off with E and it's rewrite it into ln. But ln was created to be the opposite of E. So start off with E, write it into ln, then solve it. So now we're going to do equations on the flip side of that. Equations that start off in ln format, but you have to rewrite it into E in order to do that. Okay. Now this one, we have an extra number in front of the ln. So again, before we can actually rewrite this, we actually have to get rid of the extra numbers that are around the ln as well. So 3 here, it's like it's being multiplied. So how can I get rid of that 3? Fine, yeah. Really squeaky to me. Okay. So we divide it by 3. So now we have it in ln. Oh, I added parentheses. Usually, sometimes there's parentheses around what's with the ln, sometimes there's not. I usually put parentheses around it. Don't quite know why I typed it like that for the third example. So I just put those there. So now x is trapped with ln. So in order to solve it, we have to rewrite it into the opposite of ln. What's the opposite of ln? E. Yep. So like I said, if it really helps, you can write in where the E is at. So E is right there, we just don't see it. So we're going to rewrite it into E form. So start with the E, walk around to the 4. 4 becomes an exponent. So when you're given E numbers, they're exponents, and then it equals 4x. So in the calculator, I'm going to use the e to the x button to do out e to the 4th. So that's usually second ln, and that'll give you the e, and then to the 4th power is 54.590. Like I say, with that one, usually it's second ln. So up here, I hit second, and then I get my e feature, but I still have to type the number first. So it's e to the 4th. There's my 54.598. So again, you want that e to the x feature, which is usually second ln. So hit your second ln, that'll give you e. And then that's what equals 4x. And then to solve for x, what do I need to do? Right. So x is going to equal 13.6495. I'm around that 65. This is 15.6495. So this one, however you round it, if you just cut it off at 9, I'll be okay with that. But since it was 9.5, that one made me want to round up to 9, so I did 6.5. This one doesn't have any extra numbers, so you don't need to worry about moving anything first. So what do we need to do? Rewrite it into E form. Yep, rewrite it into E form. So it's going to be e to the 6 equals 2x minus 3. So we need to solve out e to the 6. One thing I'll say is that when we're working with e, we'll be working with decimals, but sometimes they can be a little bit bigger numbers because we're taking e, which is a number that's a little bit more than 2. almost 3 and raising it to the 6th power. So we get 403.429. So we're using E to solve ln. It's okay to get maybe some larger numbers. So if you have to take E to bigger and bigger exponents, the numbers are going to get bigger and bigger and bigger. So what's my next step? Add 3. Got 406.429 equals 2x. And then what do we do? I take 406.429. Okay, 23.2. I'll round it. It was 0.2145, so I'll round it. Okay, so now I got one other example, which I realized later that your exit ticket ended up being on that page, but it'll be okay. Because this example is probably the easiest one. What do you notice that's different about this equation?
There's 2.
There's 2 ln's. When there was 2 logs, what can we do?
Cancel them out.
Cancel out. So when there's 2 ln's, what do you suppose we can do?
Cancel.
Cancel out. Because ln is just a log. It's just the natural log. So if you have 2 ln's on one on each side, again, you can cross them off just like you can any other log. So we have 2x minus 5 equals 3x plus 6. And then we just need to solve that again. So subtract 2x. Put x here. Subtract 6. Subtract negative 11. Like I said, I didn't count pages well, so your X ticket ended up on the back of that paper. But that's fine, you can still just rip it off. You'll get that paper back so you can have that example if you like. Like I said, that example is pretty straightforward because we've done solving logs in the past. So there's 2 ln equations. So you have whatever it starts off in, you have to rewrite it into its alternate to solve it. So if it starts off as an ln equation, you'll have to rewrite it into E to solve it. If it starts off as an E equation, you'll have to rewrite it into ln to solve it. So that's our X ticket, and then we also have papers.